Hey everyone, Corbin here. I have a quick but important video for you today. We are going to improve the security of our SSH connection using key pairs instead of passwords. Yes, I should have done that in the original video, but I think I got a little too distracted showing you how I could connect with my tablet. In any case, let's not waste any more time and let's get straight to it. Alright, first, let's have a reminder of our network configuration. You can use the command ipadder to get your IP address. This is the adapter I'm using, therefore my IP address is gonna be this one. And I need to find the IP address of my remote device, the billing device. I don't remember if I showed you this command already, but the command to scan your network is nmap. You can find this in your package repository using pacman or whatever is your package manager. With the option -sn and the address of your network. If you don't remember how this works, check the video number 4 in the series where I explain everything about IP addressing. And you get a list of the devices in your system, in your network, sorry. You would probably have to try each one except this one that you know is my local address. I have 2 other devices, but I know already that my billing device is this one. So that's how you can find out. Now let's move on. Okay, now the task starts for real. We need to create the key pair for our authentication. I'm not gonna go deep into this topic because it would be an hour-long video probably. But what you need to know is that these keys are created in pairs. You get a private key and a public key. The private key is a key that you should keep safe and never share, and the public key is the one you give to servers to authenticate. They are pretty much like the turtle doves in Home Alone 2. So long as both devices have their keys, they will be friends forever. So, the command SSH keygen. For this I am going to refer to the current GitHub recommendations because GitHub also uses SSH keys. And you will see that there are 2 recommended algorithms. This one that uses elliptic curves and this one that is the classic RSA with bit length of 4096. I think this one is a lot easier to remember, but I'm gonna go with this one because it's the current most modern recommendation. Now, GitHub also uses the -comment option and asks you to put your email there. I think they use it to identify the key, but I don't need that on my home setup, so I'm just gonna go with this. Now, what I am going to do is I'm gonna specify a file. If you don't specify a file, it will create a default ID RSA file or whatever algorithm it is, and that's fine. You can use the same key for all your authentications, but I want to have separate files for everything. So I'm going to specify a path which has to be inside the .ssh folder, and I'm going to call the file Aquinas. And a passphrase. So if you don't specify a passphrase, the file is going to be enough to authenticate. It's going to be pretty much automatic. But the passphrase adds a little more security because you need to give the passphrase to use the key and use the key to authenticate with the server. That depends entirely on you. I am gonna give it a passphrase, a very simple one because I'm gonna destroy it anyways. It's just a test. And there we go. Aquinas is created. It will generate 2 files. This one, the base file, is your private key. You should never share this file. You should never show this the contents of this file to anyone. And it also generates your pub file. This is the public key. This is the one that you're going to give to the servers in order to authenticate. You can see, since we didn't add a comment, it added by default your username and name of your computer. If you don't want this, because you don't want any identifying information at all, that's not a problem. Let's remove this. And we are going to create it again, but we are going to give it a comment. And it's going to be something simple. I'm just going to say user1. We give it passphrase again. And we have the new one, and you can see that it says only user1. And that's it. Our key is created. Let's move on to the next step. Okay, now we need to transfer our key to the server. For that, we use the command SSH copy ID. I'm going to specify an input file because, like I said, I am not using the default. It's going to be Aquinas public, and the custom port I gave the server, and the username and the IP address of the device. We give our password, and that's it. The key is on the server. It's simple as that. Now if I try to connect, there's my one like this. It doesn't ask for my password as usual. Now it is asking for the password to the private key. It tells that it's trying to access the private key Aquinas, but it's locked. So we give the password of the key, and bam, we are inside. That is it. We can check in the .ssh/authorized keys that our key is precisely on the server. It's the one we named user1. And that's pretty much it. Users can still use passwords to connect at this point. So if we want to prevent that, we need to change the configuration of our SSH. And we're going to do some changes here. First, I don't want to permit people logging in as user, key or not. So what we're going to do, I am going to copy, have a backup in case I forget. And I'm going to change this to no. So no root login. Just like you don't use your root user on your local computer most of the time, you don't want people logging in as root. Next, we need to enable this pub key authentication. And well, it's not here really, but for some reason. So password authentication, we're gonna say no. And I think that's it. We need to restart the SSH service. Start SSH. And I think that's it. Let's see if we can still connect. Yes, and we connect directly because it's not going to ask for your key password all the time. Once you use it once, the system is going to remember for a set period of time. So it's not going to ask for the key password again. So we're going to leave. Now, I am going to show you what happens if I try to log in from my tablet. So let's try to connect from the tablet. And it refuses. It sends an error saying that you need a key. And that's it. People cannot log in into the B-Link with a username and password. This protects you from people trying to guess, but also comes with the drawback that now you cannot connect from any device. You cannot go to a friend's house and ask for the computer for a moment and connect to your B-Link device from there. You need to have a key on each device that you want to connect with. So later I'm going to repeat the process on the tablet to have a key from the tablet to the B-Link. But that's it. We have a more secure SSH connection now. One more thing before I go. Transferring your key to the server requires your password, as you saw. If you disable password access to the device, you won't be able to transfer keys in that way. So you have two options. You can temporarily enable password access again when you want to copy more keys to the server, or you can do it physically. Put the key on a USB, go to the server, log it there, and copy the contents of the key file onto the authorized keys. And that's it. Just important to remember. Now, video is over. Thank you for watching, and see you next time.